This is 5-4 point slope form. The goal of this lesson is to show yet another method of writing the equation of a line through 2 points. So the point slope form of a line is the following: y minus y1, where y1 is the second coordinate of one of the two coordinates given to you, equals m is the slope, times x minus x1. And x1 and y1, once again, are just the 1 point given to you in the point slope equation, or one of the 2 points given to you in the point slope, or in the original problem. So what we need to do to write an equation in this form is we need to have a point and also a slope. So it says, problem 1, write an equation in point slope form. A line passes through negative 3, 6. Well, negative 3, 6 is our point. Call it x1, y1. So the negative 3 is my x1, the 6 is my y1, and we have a slope. Negative 5 is our slope. So what is the equation of the line? Well, the equation of the line in point slope form is y minus, we're going to replace y1 with 6, equals negative 5, replace the m with negative 5, x minus negative 3. And I'm placing the negative 3 in parentheses. I should probably do that with the 6 as well, because I'm substituting them in. Sometimes you'll have to clean it up a little bit in terms of signs. In this case, nothing changes on the left because the 6 is positive. On the right, because I'm plugging in a negative 3 for x1, this will become x plus 3 because I'm subtracting a negative number. So that's the equation of a line in point slope form. Sometimes we'll be asked to take the equation of the line or in point slope form and then write it in slope intercept form. Here we're just going to leave it in point slope form. All right, it says graphing using point slope form. So this time I'm given the equation of the line in point slope form, and I have to identify x1, y1, and the slope. So we talked about this earlier. All we need is 1 point on the line, and then the slope will tell us where to go from that 1 point to get as many points as we need to be able to graph the line. So here, the 1 is my y1. The 2/3 is my m, and the 2 is my x1. Notice that in the formula, y minus y1 equals m, x minus x1, there are minus signs here and here. So if you see a minus sign in the equation, as we have here and here, we know that the values of x1 and y1 have to be positive. If for some reason we had a plus sign, say right here, that was a plus sign, then that would tell me that x1 is actually the opposite of that. It's a negative 2. Same thing on the other side. If I had a plus sign over here on the left-hand side in front of that 1, I would know that the y1 is a negative 1 instead of positive. So because the formula, point slope form formula, has negative signs in there, if when it's rewritten with numerical values, numbers in it, there's no sign change, you see the minus sign showing up both times, that means both x1 and y1 are positive. If either one of those is a positive sign in there, then we have plugged in the opposite. And so it has to be negative. So once again, if this was, say, positive right here, then that would tell me x1 is actually a negative 2. So as you're going through your classwork, look for that. All right. So if I have my point, this tells me that my point, let's get rid of this. My point is 2, 1, and my slope is 2/3. I'm going to place a dot at 2, 1, and then from that dot go up 1, 2 units, and over 1, 2, 3, place another dot here. I could equivalently go down 1, 2, and left 1, 2, 3, and place a dot there as well. Draw my line in, and there it is. So graphing a line when given the equation in point slope form. All right, it says using 2 points to write an equation. So here I'm giving you a picture. You won't always be given the picture on the skill test. We're not given a picture. You could plot the 2 points and draw a picture, but here I have the points 1, 4, and 1, 4. I think I'll call that the x1, y1. And then I also have another point, -2, -3, and we'll call that x2, y2. So the reason I called the 1, 4, x1, y1 is I know that I'm going to plug those in to the equation, and they're both positive, so that'll make it a little easier for me. Before I can write the equation of the line in point slope form, which that's our goal here, we're going to write the equation line in y minus y1 equals m x minus x1 point slope form, and then what we're going to do is change it from that form into y equals mx plus b form. So let's just go ahead and plug in what we know. We have y minus y1 I said was 4. You can see it right here. So I can plug in 4 for y1, and it doesn't hurt to put it in parentheses. And then I have equals m I don't know yet. We're going to talk about how to find that in a minute. I have x minus x1 was 1. You can see it right here. I've labeled that as my x1. So here I have part of my equation in point slope form. I've just got one problem. I don't know what the slope is. So two options for finding the slope. We can see from our picture that the slope is, by counting 1, 2, 3, 4, 5, 6, 7. I go up 7, and then from here I go 1, 2, 3 over 3. So 7 over 3. So the slope is m equals 7 over 3. That's using the picture, the graph, to find my slope. My other option for finding slope is to use our slope equation, and this would avoid having to draw the graph of the line by plotting the 2 points. But I have m equals y2 minus y1 over x2 minus x1. So we'll do it this way as well. So I have labeled y2 as -3, so put -3 in for y2. y1 is 4. x2 is -2. And x1 is 1. So if I simplify this, -3 minus 4 is -7. -2 minus 1 is -3. And because I have a negative over a negative, that is a positive 7/3. So exactly the same slope I got up here by counting and looking at the picture. So if m is equal to 7/3, I can go back over here to my equation and place 7 over 3 in for m. And that is the equation of the line here. You can see I have, you clean it up and rewrite it here, but I have y minus 4 equals 7/3 x minus 1. And that's the equation of the line in point slope form. Now, you will be asked oftentimes to write this in slope intercept form. Slope intercept form is y equals mx plus b. So you may be asked to write it in that form. We can do that. It's not too difficult to do. With this 7/3 in here, it makes the arithmetic a little more difficult, but using our calculator, it's not a problem. We have the equation boxed right here. We're going to bring this down, and we're going to rewrite it. We have y minus 4 equals, so here's the goal. We're going to get y, here's our y, all by itself on the left as it is in the y equals mx plus b form. So that's the goal. What I've circled there, I'm going to get that all by itself. What I'm going to first do is distribute the 7/3 to each of the two terms up above. So I have 7/3 x minus 7/3. Then we have one more step to do. I just need to add 4 to each side. And so I have y equals, this doesn't change right here at all. We're just going to leave that 7 over 3x. 7/3 is the same as 2 and 1/3, and that is a negative 2 and 1/3. If I add 4 to negative 2 and 1/3, or in other words, subtract 2 and 1/3 away from 4, I get the value 1 and 2/3. So we could rewrite this as plus 1 and 2/3. And you can do that on your calculator using your fraction key. You just type negative 7 ABC button 3. Remember your ABC button on there. And then plus 4, and it will give you 1 2/3 as the solution. Sometimes what you may see, the way you may see this written is 7/3 x. Sometimes they will change it over to an improper fraction. So 1 times 3 is 3, and then you add 2 to it, which is 5/3. So you might see it written this way. But either one would be fine. Y equals 7/3 x plus 1 2/3. At least 1 2/3 I know, if I'm going to go then and graph this, I know where 1 2/3 is. It's, between 1 and 2 on the y-axis, a little closer to 2. 5/3 I'm going to be thinking about that as 1 2/3 when I go to graph it anyways, but you should know that either one of these that I'm boxing here are the equation of the line in slope-intercept form. So either one. Now, somebody might have the question, what would have happened had I, up here at this point, used the other point for x1, y1? What if I had plugged in that -2, -3 for x1, y1? Would I get the same equation? Well, when it comes to point-slope form, it won't look the same. Let's write it down here. But if I change it over to slope-intercept form, you will have exactly the same equation. For example, I'd have y minus, in parentheses, it would be, there's a -2, equals, and then I'd have the 7/3 and x minus, and then in parentheses, -3. And the question is, will you get the same thing when you solve this for y? It should match this right here. Let's just check that. Minus minus would make that y plus 2. Here I have the same thing. X minus a -3 is x plus 3. So, as I go through this, I have mix those up. Let's try that again. Put the -2 and the -3 in the wrong place. I apologize. One more time. So we have the -3 here and the -2 here.
Students, please come to the main office.
So this is y plus 3 and this is x plus 2.
Osdale and Savannah Williams, please come to the main office.
Okay, so now we're going to distribute. This is 7/3 x plus 7 times 2 is 14, so we're distributing here and here. 14 over 3, and here I have y plus 3. So one more step on this one. You'll see that it's going to match up with what we got earlier. I'm subtracting 3 from each side. So y equals 7/3 x. You're just going to bring that down. 14/3 is the same as 4 2/3, and I'm subtracting 3 from it, which gives me 1 2/3. Exactly the same thing I had before.
Sierra Miracle and Austin Johnson.